That mysterious underwater volcano is doing something again, and it's fascinating. Now that we have a name, Titan Ridge, in basically an area north of Papua New Guinea, has done something because this deep underwater volcano in the Pacific, it looked like it was calming down a little bit, but then the signals changed again. So if you look at that graphic behind me, we have to explain that. But you see, the higher bar is 1 month and the lower bar is what happened there in 1 year. So now it has produced a new pulse of activity after weeks of eruption. So the heat signal suddenly spiked. That is what you see in that graphic. And the underwater acoustic signals increased. That sounds a little bit mysterious, underwater acoustic signals. So the eruption has shifted from these two vent areas to mainly one active vent right now. We have a plume that rose roughly 5 kilometers, 16,400 feet above the sea level, and then lots of pumice from the eruption is now reaching nearby island shores, and that is creating problems. And we're seeing these images, the guy is holding this huge piece, and they're very light and fluffy, so they're floating on the water, which is a problem for boats or fishermen because that can really create this pumice carpet that is very dense. It makes it hard for boats to get through there or damaging the engine of boats. So pumice is doing to boat engines what the ash is doing to jet engines, for example. So it is reaching shores, nearby shores, and that is important because Titan Ridge is not a normal volcano where we can just have cameras put at it and record everything, right? Look into the crater. It is erupting from the seafloor in a part of the Bismarck Sea, so poorly mapped, so that NASA says scientists still do not know the exact active structure or the original vent depth of that volcano, although we've been watching it for weeks. Imagine that. So the most important part of that eruption is still hidden underwater. We still do not know everything. And after the Tonga disaster, that is exactly the kind of volcano and eruption that is too dangerous potentially to be ignored. So it began erupting on May 8th in the Central Bismarck Sea. I have reported about this. The eruption was first detected after a small earthquake swarm, and then satellites were catching up on it, right? They started seeing the surface evidence, like the steam-rich plumes, the discolored water, floating volcanic rock, and heat signals that were coming from the ocean. Well, why is the ocean generating heat signals? So that was the first warning, so to speak, not because this was already Tonga or everything, but because it was an underwater volcanic eruption in a complicated plate boundary zone with very little direct seafloor data. So NASA says the eruption is thought to be happening along Titan Ridge, about 16 kilometers or 10 miles southeast of a known submarine eruption that happened in 1972. But the key point is something else. Scientists do not have a clear high-resolution map of the eruption site. So that means they're watching the volcano basically through only indirect signals. We have to use satellites, heat, watercolor, acoustic pulses, ash height, and this drifting pumice. So in other words, they're reading the ocean surface to understand what's happening far below it. And at first, the eruption appeared to involve two vent areas about 2.5 kilometers or 1.6 miles apart. That was already unusual, absolutely unusual. One vent area was roughly 1.5 kilometers or just under 1 mile across, so quite long, quite large. So the other was about 500 meters or 1,640 feet wide. And that activity then decreased after May 21st. So that might look made, I wanted to say might and made it look like the eruption might be weakening. But we know volcanoes do not always end up in a straight line when it comes to their behavior. And Titan Ridge then did not go quiet. On May 22nd, a magnitude 5.7 earthquake struck near the eruption zone, really large. So official reports say it did not clearly change the eruption at that moment, but it matters because it showed the same region was still under enormous stress. And then came the bigger shift. On May 28th and 29th, hydroacoustic signals from the volcano have increased sharply. So basically that means the eruption became more active underwater again. So not just visibly from space, we could also hear it from inside the ocean audibly. Hydroacoustic signals are very important, we have to say, because sound travels very efficiently through water. So let's imagine this. When an underwater volcano releases gas, fragments of rock, or collapsed material from its underwater cone, or pulses explosively, those signals, they can move through the ocean even when, let's say, clouds hide the surface and we can't see anything. So that is why this update matters a lot, because the eruption had slowed and then the ocean started hearing it again. So by June 1st, the pattern had changed. So activity was mainly coming from the northeast vent area. So the southwest vent no longer showed the same plume activity. So that tells us that the system, the internal system of the underwater volcano has reorganized itself. So instead of two visible vents, the eruption concentrates now into one main active zone. So that can mean pressure is actually being focused into one single pathway now, not two. So it could also mean the eruption is changing shape below the surface. So both possibilities matter a lot. We also have satellite imagery that after that showed discolored water drifting about 8 kilometers, roughly 5 miles from the active vent area. And hot pumice was floating close to the surface. And the thermal detections became hotter than earlier in the eruption. So, and this is where this graphic, this Mirova chart becomes important. Around June 2nd, if you look at the data, the thermal signal spiked on roughly 226 megawatts. So by the latest update on the chart, it had dropped to about 7 megawatts again. So guys, that does not mean the eruption is over. It means the eruption is pulsing. Boof. Boof. So a deep submarine volcano can surge, weaken, surge again, because the heat signal depends on what reaches near the surface at the time the satellite passes overhead. You understand what that means? So if very hot pumice or fresh material reaches the surface, Mirova sees a spike. If clouds block the view, for example, or the hottest material disperses, the signal can drop. So that does not mean the eruption dropped, actually. So the important thing is not just one number. The important thing is the jump that we have seen. Titan Ridge produced a much stronger thermal pulse than earlier in the eruption. And it did that while the underwater acoustic signals were also rising. So then from June 2nd to June 4th, the plume rose to about 5 kilometers, 16,400 feet above sea level. So for a volcano that is hidden underneath the sea, that is not a minor surface disturbance. It's not minor at all. So that is a direct atmospheric signal from an eruption that began underwater. So plume height matters because seawater normally suppresses explosive energy, right? And the weight of the seawater, but it still broke through. So the deeper the vent, the more pressure the water applies. So The fact that material still reaches the air as a tall plume, tall, that is also important. It tells us that the eruption has enough energy, gas, or shallow interaction to break through the ocean's pressure filter, as we can call it. And so why is the depth question so important? Some reports say that the eruption, as beginning around 500 to 600 meters, or about 1,640 to 1,970 feet below the surface. So NASA is way more cautious and says the exact active vent depth is still uncertain. And that uncertainty is the danger. That uncertainty is the danger, because depth controls explosivity. A deep vent can release material into the ocean with less surface violence. Shallower vent can allow seawater and magma to interact more violently. That's when the bad stuff happens, right? If the vent is building upwards, the pressure drops because it's erupting and it's building up. That's how islands sometimes are formed. So if a cone grows from loose volcanic material, that cone can become unstable. And that's when we have a high tsunami risk, because if part of that unstable cone collapses, it can displace water suddenly. And we know what that means, right? That is that tsunami mechanism that people need to understand. Not every underwater volcanic eruption will make a tsunami, I want to say that. Most do not, thankfully. And there is no confirmed Pacific-wide tsunami threat from Titan Ridge right now. I also want to say that. But as we've seen with Tonga, underwater volcanoes can generate local waves in more than one way. Local waves are dangerous too, not just the ones that spread across the Pacific. A blast can push water, a cone can collapse, submarine landslide can move material downslope, gas explosion can disturb the surface, and a sudden failure of a growing volcanic platform can displace water faster than anyone would expect, right? That is why we compare it to Tonga, not because Titan Ridge is producing a Tonga-scale eruption, at least not yet, right? It's not. Tonga was a much more violent event, and the tsunami involved multiple mechanisms, including the explosion, the water displacement, atmospheric pressure waves, and collapse processes. But Tonga has proved to us that underwater volcanoes can create hazards that do not behave like a normal earthquake, tsunami, for example, right? Titan Ridge belong to that same broad category like Tonga. It's a hidden submarine system where the most important action is actually happening below the waterline. And now this eruption is reaching people in a very practical way. The pumice has started washing onto the shores of the Admiralty Islands. So for fishermen and boat, that is not just a strange beach event, as I mentioned, right? That pumice can form basically a raft that can also drift with currents and move its location. Also, we have local reports earlier in the eruption that it made thunder-like sounds and that it was smelling like metal was burning. And that detail matters because it gives the eruption another layer, right? People were not just seeing the satellite plume, they were really experiencing this eruption. So the biggest mistake now would be to look at the latest low thermal anomaly and say the danger is gone. That chart does not show a dead volcano. It shows a fluctuating one. So we want to know whether that seafloor structure below the Bismarck Sea is now still growing, cracking, or reorganizing. What is it doing? We don't know. So the latest data as of right now is just telling us it's still changing. The ocean is still hiding the main event, and I'll be on the pulse of that for you. I hope you liked it. And I want to show you something for those of you that haven't seen it yet. First time on camera, when an earthquake took place, a large earthquake, how the ground was cracking open and moving. So this shows on camera where something's standing here and something standing here, and then the ground moved and it's displaced. Absolutely amazing footage, guys. Click here.